Hello, today we are going to learn engineering mechanics. So, in the chapter 1, we are going to learn the fundamentals of engineering mechanics. Well, so first thing, what is mechanics? Mechanics deals with the behavior of physical bodies under the action of force or system of forces. You know the physical bodies, yes? So, the beam, column, all are the members of the structures. Football, an arrow, wedge, ball, roller, these are the solid bodies. When we apply force on the solid bodies, then what kind of action is going on? That basically we see in mechanics. Yes. So what we learn from mechanics? Basically in this picture you can see, in the first picture you can see somebody is pushing the cart. In the second one somebody is pulling an arrow. Third one, there is an example of magnetism and its effect. Third one, you can see the action of the gravity, that suppose some fruit is falling under the action of gravity. Now you can see the frictional force. Here you can see the acceleration. So there are many examples where you can see the motion of the physical body due to the action of the force. So basically in mechanics, we study about the physical bodies, and these physical bodies are basically, we divide these physical bodies into three kinds. One, rigid body, deformable body, and the fluid body. Rigid body, you know, the body which does not deform under the action of force. That means its shape and size will not change. Okay. Suppose you will take an object, you will apply a load on that object, and after applying the load, the shape and size of the object is not changing. That means there is no deformation. That body will be considered as rigid. Yes? Then what is deformable body? When you apply a load to the body, suppose its shape and size uh, gets changed, then that body is the deformable body. Basically, we study about the deformable body in strength of material. Okay, but in mechanics, we study about the rigid body. And the third one is the fluid body. When in case of fluid, basically we study about the fluid in the fluid mechanics. So we study the mechanics in case of the rigid bodies, deformable bodies, and fluid bodies. And all these parts we will not discuss in this lecture. We are only focusing about the mechanics on the rigid body. Okay. So how this mechanics is studied? What are the branches of this mechanics? So we can divide the mechanics into statics and dynamics. As you can see, it has two parts. What is statics? What we learn from statics? Suppose if an object is at rest and we apply the force and the object tends to move, at that time we study the statics, where we will study the behavior of the object which tends to move. Then what is dynamics then? Dynamics, in the case you can see, suppose an object is moving. Suppose a ball is rolling on the ground. So that ball which is in motion is a dynamic body. And in this dynamic body we study about the force which is causing the motion, what is the direction of motion, how much distance it is covered, what is the velocity, what is the displacement. All these things we study in that moving object. So that is the dynamics. So when an object is in motion, we study its dynamics. When an object is at rest and force is applied, then we study its statics. So this dynamics has its two parts. One is kinematics and another one is kinetics. What is kinematics? Where we study kinematics. So that means in kinematics, basically we study about the motion of the body. As you know, there are different kinds of motion: rectilinear motion, curvilinear motions, oscillatory motion, simple harmonic motions. So what happens in those cases when a body is subjected to force? We study in the kinematics. And in kinetics, basically, suppose two objects will collide. When two objects will collide, one object will hit another object. Then how much force is there? What is the restoring force? What will be their momentum? What will be the velocities? And everything will study, getting the force, velocities, all these things in the kinetics. Okay. So this is how the mechanics is branched. Basically, we are dealing with the statics in the beginning. Then in the dynamic part, we will deal with the dynamics. So in our syllabus, we will read on both statics and dynamics. Okay. So here I can say what we are going to learn in this subject. We are going to learn about the statics and dynamics on rigid bodies, not deformable. We are going to learn about the statics and dynamics on the rigid bodies. You know. Then some basic thing. Before you learning mechanics, first we must consider some assumption. The first one, rigid body. We have to consider that all the objects on which we are learning mechanics are rigid. That means there is no deformation, there is no change in shape and size. All solid bodies are rigid. This is our first assumption. Second, we'll consider the body, physical body, the solid body as a particle. We will discuss the numerical, like how a particle is there and force of 50 Newton is acting upon the particle like this. So consider the object as the particle, and then so what are the forces are acting on the particle. Suppose in this figure you can see this is a ball or roller. We'll take this ball as a particle and you will apply forces on this ball, but in figure you will consider that this one is a particle and forces are acting on this particle. Suppose this is the football. On the football there are two forces which is acting here. Football is at rest, but its weight is acting vertically downward. That means the weight of the football is the action which is acting on the ground, and the ground is imparting the upward reaction force. This is the ground reaction. So we will consider this football as a particle and these two forces are acting on the particle. Simple. And the third point is we will discuss on point load. Consider all the loads acting on the object as point load. Actually, we consider the loads as point load and distributed load. Distributed load means the load which is acting upon the some area. But in point load, we consider the load acting is on the point area. Okay. Suppose in this case, you can see the football is here and you apply a force to the football. Suppose someone is kicking the football here at this point. So this area is the point area where the force is applied. So that force is considered as the point load. Okay. So three things you must assume before learning the mechanics. First one, the rigid body. Second one, the particle. Third one is the point load. And here is the description. Okay. So three things we'll consider. And now in this chapter, we'll study about the force and force system. What is force and what is this force system? We'll discuss one by one. Okay. So first thing, you can see around us So many objects are there. We can see the static objects, we can see the dynamic objects. Okay. Some example I am taking. Suppose someone is riding the bike and you are standing here and someone is passing in front of you. What happens? The bike is just passed in front of you. The bike is in motion. Without any force, that bike will not move. So there is some force which is helping the bike to move in that direction. Yes. Similarly, when we are ringing the bell, we are applying force on the bell by striking the bell. We can imparting force on the bell. Yes or no? So everywhere there is force. You are pulling the door, you are pushing the door, you are opening the window. Yes, in every cases there is force. So what is that force? The force is the physical quantity which can change the state of rest or motion of a body. Force is a physical quantity, yes. This is a derived quantity, yes. So what it does? It changes the state of rest or motion. That means an object is at rest. So in the previous slide, you can see an object is at rest. You are applying force, then the object will move. Now you can see this one is the button. When you apply force, then it will be switch on. Yes. So that force is the pushing force. And here someone is pulling the arrow. So when you will pull the string, then that means there is the pulling force when you are pulling the string. Okay. So every force, maybe it is push or it is pull. Two kind of action will be there. Either it is a pushing force or it is a pulling force. Yes. So what happens when you are pulling or pushing? That means you are giving force to the object will move. Okay. So that means an object is at rest, you are applying force to move it. Second point, if a object is in motion. Okay. If we will oppose the motion, you will give some blockage, then object will stop. Like braking in the cycle, braking in bike, braking in cars. Yes. You are playing football. Suppose some of your friend is striking the football from the goalpost area to the center and you are there. You stop the football at your feet. Yes. What happened? Simply you are retarding the motion. So we can apply the force to give motion to the object, or we can retard the motion and we can stop the motion. Okay. So here the force is the pull or push, and this pull and push can produce some effects. What kind of effect? It matters. If you are opening the door, that means you are pulling the handle. So there is a pulling force, and pulling force produce some effect. Yes. So many examples are there about this pull and push. Here are some examples that I have shown you. Okay. Next one, force is a vector quantity. What is a vector? You have learned about the vector in physics. The vector is the quantity like force, velocity, displacement. These are the vector quantities, and these quantities have both magnitude and direction. Vector quantities have both magnitude and direction. What is the magnitude and what is that direction? And what is vector quantity? Simply I am telling an object is moving. So there is some displacement. Displacement means how much is the magnitude. Suppose the magnitude is 10. Two objects are moving. One's magnitude is 10, another one having 20. So how much distance will be covered by the second body? That is 20. How much distance will be covered by the first body? That is 10. So magnitude defines the value. Yes. So magnitude defines the value. Suppose I am purchasing sugar from the market and the shopkeeper is giving 1 kilo sugar to me, and secondly he is giving 2 kilo of sugar to me. So the magnitude is increasing in the second case by 1 kilo. That means that value defines what is the magnitude, but what is direction. Suppose there is a football and someone is striking the football at its center so that the football is rolling on the ground. That is one direction of motion. But someone is just giving force at the bottom of the football so that it is moving in a projectile path. Okay, suppose it is moving towards the sky in a projectile motion, it will drop at a point. What is that? That means it depends. You are applying force at what point? So there is some difference, no? So force is a vector quantity. Then we can characterize this force by 5 different points. First one is the magnitude. Suppose here you take the example. Suppose something there. Considering one thing. Suppose this is the center. At the center, I am applying force to a particle. When you are applying the force, suppose I have sensed that this is the direction of motion. I have sensed that. If an object is there, I will apply force to this object, then the object will move in this direction. So this is my sense. So this is the sense of direction. Okay, where the object will move. But when I am applying the force here, there is a line of action which will be followed by the object after applying force. So that means when you are applying force, that means automatically the object will follow this line and move along this line. What is that? This line is the line of action. Next, when you are applying the force, and if this is the line of action, suppose this one is the horizontal, that this line, or you are taking the x-axis or whatever. So this direction, this line of action is making some angle with this horizontal, and that means you are defining the direction of that force. That suppose this force of 10 Newton is applied at 45 degree to the horizontal. That means this angle is 45. Force is applied at a 45 degree direction. So this one is the direction. Already I am discussed about this magnitude. Next, point of application. When you are applying the force at a point, suppose in this figure you can see you are applying the force here. So this is the connecting point where the force is applied. So here you are applying the force at this point. So this point is the point of application or point of action. So the point where force is applied is known as the point of application. Next one, the nature of force. What kind of force is applied? Either it is a pull or push. You have to mention, because pulling force having some different effect and pushing force having some different effect. So it is a pull or push. First you know. So before you characterize a force, know these 5 points. What is the magnitude of the force? What is the direction of the force? What is the line of action? Then the point of application. Then the nature. Either it is a pull or push. If these 5 points are defined, then only we can understand a force and what the force will produce. Yes. So, and the last one, what is the unit of force? Basically, we study the unit in CG system, MKS system, SI system, FPS system, basically in physics. But what we are going to learn, that is the SI system. Basically, we will discuss all the numerical in SI system. So here the SI unit of the force is Newton. What is 1 Newton force? 1 Newton force means whenever you are applying the 1 Newton of force to the object of mass 1 kg, it will accelerate it by 1 meter per second square. Okay, so Newton is the SI unit of force, then dyne is the CGS unit of force, and there is a conversion. 1 Newton is 10 to the power 5 dyne, so it will help you in the numerical. Okay, this is force and force system. Then this, when your force will be applied, it will produce some effect. So what is the effect of this force? You can see when you are applying the force on the object, what will happen? The force can change the motion of a body. Yes, force can change the motion of body. Suppose ceiling fan is there. You have set the regulator at 3 and the ceiling fan is moving slowly, but when you are turning the regulator to, or setting the regulator to 4 or 5, suddenly the force changed and you can see the fan is moving very fast. So that means you are increasing the force. Okay. Similarly, when you are riding the bicycle, you are pedaling on the bicycle to move it. That means when the bicycle is at rest, you are applying force so that the bicycle moves. Yes or no? So that means we are producing motion by giving force. So when apply the brake, the bicycle stops. That means we are decelerating the speed. That means we are retarding the motion. We are opposing the motion. So we can produce motion and we can destroy motion by the help of force. And the next one is the internal stresses. When you apply the force to the object, that means it is a solid body. If it is a solid body, then it has some strength. So when some load will act on that solid body, then some internal stresses. Internal stresses means the internal resistance that a body can offer to the external load is the internal stress. So it also happens. Basically, we study about these internal stresses in strength of material. Okay. And the last one is can change the shape and size of a body. That means it can produce deformation. It can cause deformation. Okay. And the last 2 points we discuss in strength of material, but in the statics and dynamics, basically we study about this upper 2 points. Okay. So this is all about the force and force system. So this is the topic force and force system that we are going to learn in the next class. So thank you all very much for listening. If you have any queries, then you will talk to me. Thank you all.